Hey everyone, this is going to be my video for the chapter review and the chapter test for chapter 3. It's been a long time since we started the chapter, so I felt like I'd want to do a quick little review for you. I'm going to go quickly because there's 17 questions and I don't want this video to get too long, but this can be something you use to guide you through the chapter practice test, study guide, whatever you want to call it, and then the real test, which you'll take, and that will count for big time. So the first question is going to ask you which one of these to categorize them as a function or not a function. Remember, the big idea when you're talking about a function, each input can only have one output. So like something here, the number 1, does it only go to one output? Yes, yes, yes. This is a function right here. If for some reason we would have switched it where like maybe this number 1, instead of pointing to the 7, it points to the 7 and to the 8, where the number 1 all of a sudden goes with 2 outputs, then we would switch our answer to no. If they give it to you in ordered pairs, you just look and see, do my input numbers ever repeat themselves? And look, the number 3 right here pairs up with 5, but then later on the number 3 pairs up with 1. So that is not a function. It doesn't matter. These output numbers, if they're the same, that doesn't matter. You're only looking at the input numbers. Same thing down here if they write it as an X and Y input-output table. As long as the input numbers are all different, you're okay. Like, I don't even need to look at this. This doesn't even play a factor at all. If all the input numbers are different, yes, it is a function. So this one, yes, it would be a function. Okay, that's question number 1. Number 2 is going to give you an equation. It's not going to be this equation, but it's going to be something similar to this. And it's going to ask you for the independent variable, the dependent variable, the domain, and the range. And so in my example, the function m equals 10h plus 100 represents the money, letter M, that you make after babysitting for h hours. So M for money, H for hours. H is equal to 1, 2, or 3. So you must be babysitting for up to 3 hours here. The independent variable will always be the number kind of in this location, right? Or I guess I shouldn't say number, the letter in this location. So in this case, the independent variable is H, or the amount of hours, right? But you'll just put H. You won't have to type the word hours. The dependent variable is what it's going to equal, in this case the M, or it's technically money, but all you have to put is the letter M. The domain is a collection of all the input numbers. So in this case, what numbers were we plugging into this problem, 1, 2, or 3? The domain is going to be the 3 numbers we would plug into this problem. So if I only babysat for 1 hour, how much money would I make, right? 100, 10 times 1 plus 100. So that would be like 110. This is my range. Whatever I get when I plug all these in for my answer, that's going to be my range. If I put 2 in here, 10 times 2, that's 20. 20 plus 100, $120. If I put 3 in here, 10 times 3, that's 30. 30 plus 100 is 130. So those 3 numbers are my outputs. The amount of money depends on how much I babysit, and that is the range. A range is a collection of all the outputs. So that's how you'll do that one on number 2. Okay, on to number 3. Number 3 and 4 are going to be covering the lesson that we did about linear versus nonlinear functions. How can you tell if something is linear or nonlinear? Well, if it's a graph, it's super easy. A linear is always going to be in the shape of a line. The nonlinear ones are not going to be a line. They might have curves. They might have changes of direction. They might have bends in them. The other thing is if it's a table, a linear function will always have a constant rate of change, where nonlinear is not going to be a constant rate of change. What does that mean? Linear ones will be consistent. Like, look at this. The x's are counting by 4, right? 6 plus 4 equals 10. 10 plus 4 equals 14. 14 plus 4 equals 18. So the x's are looking good. If the y's follow the same pattern, we will have a linear function. 5 plus 4 equals 9. 9 plus 5 equals 14. 14 plus 6. See how this is not consistent, right? These slopes are not all the same. Technically, this is the slope, right? Between these two, the slope is 4 over 4. Between these two, the slope is 5 over 4. And then between those two, the slope is 6 over 4. This is not a consistent slope, so this is non-linear. But something like this next one, I think, is linear. If you look at it, from 2 to 7 is adding 5. From 7 to 12 is adding 5. From 12 to 17 is adding 5. And then down here on the bottom, from 2 to negative 1, that's minus 3. From negative 1 to negative 4, that's minus 3. From negative 4 to negative 7, that's also minus 3. Do you see how this was the same all the way across? All of these have a consistent slope of, right, 5 on the x's and negative 3 on the y's. So yes, this one is linear. There'll be one question on number 4 asking you about which equations are linear equations or functions when it's written as an actual equation. What are you looking for? You're looking to see if it can be written in this format, y equals mx plus b. So what that means is you can't have anything that's squared or cubed or to the 4th power. You can't have variables that have different exponents. It can only be to the 1st power. You can't have any absolute value in there. You can't have any square root in there. You can't have anything that looks like this, where the x is in the denominator of a dividing problem. You can have fractions, like it's okay to have a fraction, like this is actually okay, because this is like 1/2 x. You can have a slope of 1/2. The x can be in the numerator, but the x cannot be in the denominator, right? Why can't the x be in the denominator? Because if you put 0 in here, it would be impossible. We cannot divide by 0. You can have 0 on top, that's completely legal, but you can't have 0 in the denominator, so that's something else to look out for. But that is going to be 3 and 4. Number 5, one more, discrete and continuous, was another lesson that we did. This time it's going to ask you, it's going to give you a situation and it's going to ask you which graph represents the situation. You need to decide what the graph should look like based on whether it's discrete data or continuous data. Remember, discrete is where you cannot have decimals and you cannot have fractions, like the number of kids that you babysit or how many books you buy at a bookstore. And then continuous would be something where decimals and fractions is possible, like the amount of time you spend in a store, or how much your apples weigh when you go to the grocery store and purchase a bunch of apples, where decimals are possible. So this is your equation, y equals 60 minus 80x. It represents the money you have after you buy X movie tickets. That's really important right here. Your input, your independent variable, is movie tickets. Could I buy a fraction of a movie ticket or a decimal of a movie ticket? I could not. So that means this is discrete. And when this is discrete, your graph should look like this, right? It'll be points that are not connected. It would probably start up here at 60 because that's how much money you have to start out. And then it would go down by 8 every time, right? 60, down 8 over 1, down 8 over 1, down 8 over 1. But the key point here is the dots would not be connected because you could not buy a half of a ticket or a third of a ticket. Okay, we're hanging in there. I don't know how fast my time is going here, but here's 6 and 7. Another one that I just talked about on discrete versus continuous. Discrete graphs will always have separate points. There is a situation where you cannot have decimals. Continuous graphs will have a line, and the line will be connected because decimals and fractions are possible. I think the question you're going to get is like you're riding a bike or you're swimming in a you're floating in a canoe or something, and it's going to ask you which graph shows you floating in the canoe or riding the bike for a certain amount of time. Say like, hey, you have a 5-hour bike ride. Which graph would show that? Right? So in that, if that was the case, if it was the time you spent on a bike or the time you spent in a boat, you could have a fraction of an hour. You could have a fraction of a minute. I could spend a fraction of a whatever. So this one would be a line. But then if they say, hey, you only spend 5 hours on the bike, then it would stop, right? It would not go to infinity and beyond. If they say, hey, you were only on this bike for 5 hours. Otherwise, that would, in theory, be like you're on the bike forever, and that's not what's happening. You're only on the bike for a few hours. Okay, number 7 is going to be super easy. It's going to give you a function, and then it's going to ask you to evaluate it. All that means is you take this number and plug it in for the spot of the x, and then work it out. So like 3 times negative 2 minus 9, and then just work it out. And they'll give you another one. Put 0 in there. 3 times 0 minus 9, and work it out. And then they'll give you 2. 3 times 2 minus 9, and work it out. Just substitute the number in, work it out. That's like the easiest question on the whole thing. One of the harder questions on the whole thing is number 8. And this kind of tricked us whenever we saw it in the regular assignment, but I kept it in the test because this is important. It's definitely something that they'll ask you at the end of the year when we do the EOC test. It's going to try to trick you because look how, well, let me just read it. The miles a ship is from its destination is f of x equals 100 minus 10x. The miles a car is from its destination, x hours after leaving a city, is shown in this graph. And so then it asks you the ship traveled how many miles and how many hours. The car traveled how many miles and how many hours. Your eyes are drawn to this because it's so visual. But they've actually given you 2 pieces of information, right? They gave you the ship way up here. They gave you one piece of information as an equation. They gave you the other piece, the car, as the graph, right? And so they've kind of tried to trick your eyes because your eyes are drawn to the graph, and that's only about the car. But they've hidden the ship information up here as well. So we have to be really aware that there's actually two equations here, two situations that they've represented. One is in an equation, one is in a graph. Let's do this one first. The ship traveled how many miles and how many hours? The ship is my orange one that I've highlighted, right up here. Okay, how do I know where the ship started? Well, this is your y-intercept. It's going to have, since it has 100 at the beginning, this thing's going 100 miles. And then look, this is your slope, right? Remember the slope is always the one that's connected to the letter x. It's always what the x is being multiplied by. This ship is going 10 miles an hour. So how do I find how many hours it takes? You do this number divided by this number, 100 divided by 10. So all I have to do is 100 divided by 10, and that is obviously 10, so it would go 100 miles in 10 hours. And now for the green one, the car is so much easier, no one's going to mess up the car. The car traveled how many miles in how many hours? Well, look, it starts way up here at 60, so it goes 60 miles. And then how long did it take it to reach its destination? Just follow the line down, boom, right here. It took it 2 hours, because this is on the number 2. So the car is going 30 miles an hour, right? It goes 60 miles in 2 hours, so it's traveling 30 miles an hour, even though they didn't ask us that. But don't get fooled on that one, because they'll fool you by putting one as a graph and one as a sentence. Okay, number 9 and 10 are just going to be graphing simple lines. Super easy. I did a few on here. Remember, the tricky ones, if it's x equals 3, you go on you would have like an x and y table like this, where the x has to be 3, and then you can pick whatever number you want for the y. This will be a vertical line. 3, 1, 3, 2, 3, 3, right? X equals 3. If it's x equals, it's going to be a vertical line, straight up and down, that has undefined slope. The next example where it says y equals, you can't really tell that's a y, I kind of smeared it there, y equals -5. This would be a chart where the y has to equal -5, and then you pick whatever you want for the x's. This is going to be a horizontal line. Whoops, I didn't connect it right through there. But this would be a horizontal line. Y equals is always going to be a horizontal line. And then they'll give you one on number 10 where it is both the x and the y are there. And that's when you'll have to do the plug 0 in for x to find the y-intercept, and then plug 0 in for y to find the x-intercept. Do you remember how we did that? It's been a long time. If I put 0 in for x, 4 times 0 plus 3y equals 12. Okay, 4 times 0 is 0, so I really don't need it. Really all I need to do, I can just almost erase that. I can just solve this. 3 times what equals 12? Y equals 4. So on the y-axis, I can go to 4. Right here. Okay? And then do the same thing, but now with I'm going to put 0 in the spot of the y. So now if I do it again and I substitute 0 in for the y, that's going to help me solve for the x-intercept. And you get 4x plus 3 times 0 is 0 equals 12. The plus 0 is really kind of pointless because adding 0 doesn't do anything. And you have 4x equals 12. 4 times what equals 12? That's easy. 3. So on the x-axis, the side-to-side one, I go to 3, put my dot, and then I connect those two lines. And that would be my equation, 4x plus 3y equals 12, right there. Okay, so if it's just an x or just a y, it's going to be straight up and down or straight across. If it has x and y, it will always be diagonal. And do this to help you on that one. Okay, my time, 13 minutes. I'm hanging in there better than I thought. 11 and 12. It's going to ask you super easy questions. What is the slope on number 11? Holy cow. Remember, when you read slope as a graph, you go from left to right. Just like when you read a sentence in English, you read a sentence from left to right. So I put my little stick figure, Tim and Moby, up here. I'm going to travel from the dot on the left to the dot on the right. And remember, it's always going to be rise over run. And here, in order to get, I'm starting here, I'm going to end up down there. I don't actually rise, I'm actually dropping down. How many spots is this? I'm going down 1, 2, 3. Down 3, and then I'm going over, running over 1, 2, 3, 4. See, I'm counting the spaces. Over 4. Now, the fact that I went down means this cannot be positive. This has to be negative 3 over 4. And that's how you'll do that. And then they'll give you super easy ones that are in slope-intercept form already. It'll ask you, what is the slope? What is the intercept? Remember, this is the slope, whatever the letter x is being multiplied by. So on this one, the slope is 2/5. On this one, the slope isn't there, so it's really an imaginary 1. On this one, the slope is right there. It's 1/3. And then the y-intercept, or the letter b, is always the adding or subtracting part at the end, right? This is the y-intercept. On this one, it's -6. On this one, it's +1. On this one, there isn't anything, so the y-intercept is 0. And that's number 12. We just have a few more. Only a few more. We've only got to get to 17. Oh boy. 13 looks like it's going to make you cry. But trust me, it's so not as hard as it looks. I made it up a little different. In your real question, it's a hot air balloon. I call this one a drone. And it says you've got this drone that has this equation whenever you notice it up in the sky. And here's your graph. Boom, 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 boom. It's got this little dashed line. It looks super confusing because look at all these answers you have to type. Holy smokes. Trust me, guys, it's not that bad. Oh, and I kind of smeared it already. Okay. Look at what this graph shows. It shows the drone starting out as at an elevation of 100, and then it slowly is coming downhill, downhill. It's coming slowly lowering in the sky, and it eventually, after 20 seconds, it is at an elevation of 0. So after 20 seconds, this drone is on the ground, right? So it says the domain. The domain is all the input values, all of your x values. The domain is how long was this drone in the air from here to here. This is your domain. How long was the drone, how much time was the drone in the air? It started at 0 seconds, it goes all the way to 20 seconds. Easy. What is the range? The range is the, notice they said the letter H, is the height. The range is what outputs here, what y values, how high did this drone get? And how low did it fall? It started at 100 and it went all the way down to 0. So the range is between 0 and 100. How much of the y-axis did this graph use, right? The domain is how much of the x-axis did the graph use. The range is how much of the y-axis did the graph use. The slope is right here. It's in the equation. The slope is telling you how many, in this case, -5. And that is, whoops, and I smeared it here. The slope is -5, so the change in height is -5 feet per second, right? That -5 is representing this drone is coming down at a speed, at a rate of 5 feet every second. Downhill, right? That's why I put negative. The h-intercept, this is actually h because they have an h right here instead of, it's usually called the y-intercept, but in this case it's the h. The h-intercept is where did the line touch the y-axis? Way up here. The h-intercept is 100. So the height was, it was 100 feet in the air when you first noticed it. And then it says the x-intercept, where did this line touch the x-axis? Boom, right here at 20. The x-intercept is 20, which means it took 20 seconds for the drone to come down to the ground. Okay, so that question looked very crazy, but it's just talking about the basics of the graph. Rewind that and watch it again if you need to when you get to number 13. Okay, only 2 boards left. Super easy. This is what we've been doing the last couple days. These questions, I hope, are the best. They're going to ask you, you have a, we're going to transform this function into these functions right here, and they're just going to ask you, what did you do to transform it from this to this? These are lines because there's no absolute value in there. But you started out with this, which is okay, but look what you've done. On this one, you've put +5 at the end. The g of x is equal to f of x plus 5 more. Remember what that is? If they add 5 at the end, it's a vertical translation, and it's 5 units up. If this would have been -5, we would have said 5 units down. And then on the next one, where it has this, now all of a sudden the -6 is in the parentheses. It's in the parentheses with the x, with the input, with the independent variable. When the number and the operation is inside, now it's a horizontal translation. And when you have horizontal translations, it's the opposite of what you think. -6 is not 6 to the left. -6 is 6 to the right. +6 would have been 6 to the left. Okay, and then down below, they've kind of combined some together. They've done a couple things. They said, all right, now on this one, you're going to start out with the basic one, the easiest one you can do. And look what you've done. You've made it this. Y equals, or m of x equals 1/4 x minus 3. Okay, the 1/4 in front of the x is where you have done a shrink or a stretch. How do I know if this is a shrink or a stretch? Well, this one has a slope of 1. This one has a slope of 1/4. I've made that lower. So I've done a vertical shrink by a factor of 1/4. That's what we have done when we change the slope. And then we also put this -3 at the end. And -3 at the end is just kind of like it was up here. So then we've also done a vertical translation 3 units down, or maybe they would put it as down 3 units. They might kind of rearrange those words. So we've done 2 things on that one. On number 15, there will be a combination, at least 2 different things that are happening. Okay, and then our final board is about the absolute value ones. They're going to give you some graphs and you have to match them up. Remember how these look, right? The basic one is always going to have the vertex at the origin, and then it's going to go up 1, 1 to the right, or up 1, 1 to the left. The basic one is going to look like this. And then everything else, all of these over here, are variations of this one right here. And it's very similar to what we just had. So like this one, the +2 is inside the absolute value. So this is like a horizontal one. This is going to go right or left. But whenever it's horizontal, it's always the opposite of the way that it looks. This is actually 2 to the left. So like this one would be scooted over, and the vertex, instead of being right here, the vertex would be right here, and then it would go up 1 and over 1, and up 1 and over 1. So that one would kind of look like that. It would be scooted over 2 to the left. This one, in green, this one has the +2 at the end. This is going to be a vertical translation. This is going to be up 2. And so this one, instead of having a vertex at the origin, is going to be straight up 2. That's the new vertex, and then it's going to be up 1 over 1, up 1, 1 to the left. That one's going to look like this. It's just going to go straight up 2 places. This one I never really showed very often. Whenever this is 2 times x, this is going to be twice as steep, right? This is going to have a slope of 2 instead of a slope of 1. So it's still going to be on the origin, but instead of being up 1 over 1, it's going to be up 2 over 1 and up 2 over 1. This one is going to be steeper and narrower. You see how that letter V is, it's tighter together instead of being the basic one like this. It's kind of, it's tightened itself up. This one, if the slope is less than 1, I don't really have a new color. I'm just going to have to use black, I guess. When the slope has gotten smaller, the slope is down to 1/2. This is going to be the opposite of the purple one. Instead of getting tighter, this one's going to get more wide open. So the vertex is still going to be here at the origin, but instead of going up 1 over 1, I'm going to go up 1 over 2. So this one's going to be flatter. This one's going to be, look at this one compared to the red one. See how the red one goes right here, and this black one is more wide open? So that is that. And then the very last one, if they put a negative on here, they flipped it upside down, but this one is flipped upside down, and it's 4 times as steep. So this one is going to be like going downhill, and it's going to be 4 over 1. It's going to be like down 4 over 1, down 4 over 1. This thing is flipped upside down, and it's super steep. The slope is 4 over 1, down 4 over 1, down 4 over 1. Okay, that's going to help you on 16 and 17. I hope this can give you some help on the test and on the study guide. Please send me a question if you need help on a specific problem that maybe my explanation here was too fast or you didn't quite get. All right, I'll catch you in another one, guys. Good luck.